This is lesson 5.3 on comparing and ordering fractions and decimals. Before watching the recording, please make sure that you have either a graph sheet of paper or your math journal with you, and you may go ahead and write down what you see on the screen here. So today's date, lesson being 5.3, if it is still 5.3, and I'm going to give you a couple of minutes, and actually right after this, pause the video, write down mixed number and improper fraction as you see here, and think about the definitions of both and come up with an example of both a mixed number and an improper fraction. So again, I encourage you now to pause the video to do that. So I'm going to continue. Look at your definitions that you came up with mixed number and improper fraction. So let's start off with mixed number first. So a mixed number, if you remember from previous years, is a combination, and however you worded it, similar to this is fine. A combination of a whole number and a fraction. So one example would be, let's do 1 3/4. Okay, so again, you have the whole number here being 1, and then you've got the fraction portion attached to it. An improper fraction is where the numerator, a fraction where the numerator is larger than the denominator. That's what makes it improper. So and the example would be 7/4. So you should know the terminology, but I'll review. The 7 is the numerator, or the number on top, and the 4 is the denominator. Remember that math vocabulary is always important. Okay, so I'm going to highlight those definitions. Also going to highlight the numerator and denominator here, because those are things that you shouldn't forget. So we have a mixed number and an improper fraction. Sometimes it also helps when reviewing a concept is to look at the visual. So say, and actually what's nice about the two examples here is that they are the equivalent to each other, and we'll review that in a second. So if you took 1 3/4, so I'll make that closer. If you took 1 3/4 and you were to draw a picture representing that, 1. Okay. And then if I were to draw and split each circle into quarters, oops, let's redo that one. Okay, it's as close to equivalent parts as possible. So we were to fill in, actually, okay, so this is the whole. Okay, and then I'm shading in. Okay, as much as possible. So this represents, again, these two pieces together represent one whole, and 3 out of the 4 pieces are shaded, so that's 3/4, right? So that's why it represents the mixed number 1 3/4. Now, what's nice about this is that you can easily see the equivalent improper fraction. The total number of pieces we have altogether, if you look at each circle individually, each circle is split into 4 pieces. How many pieces are shaded? Altogether, it's 7. So we count 1, 2, 3, 4, 5, 6, 7. So that's why 1 whole and 3/4 is also equivalent to 7/4. Notice that the denominator is the same in both cases. Okay, so That's key when you convert mixed numbers to improper fractions or the other way. Another way to look at it, if you remember, is the following. So again, if we take that same example mathematically, 1 3/4, it's always easier, I find, to convert from a mixed number to an improper fraction because the operations are a little bit easier to do. So when you're converting a mixed number to an improper fraction, remember that what you're doing is you're multiplying the numerator by the whole number first. And then you're going to take that number, and you're going to add the numerator, okay? So remember what was said before was that the denominator stays the same in both cases. So you know that it's going to be the same denominator. We're just going to convert it to an improper fraction. So what you're doing is, what's 1 times, so again, follow the cycle. What's 1 times 4? It is 4. What's 4 plus 3? It's 7. So that's why the equivalent improper fraction is 7/4. So let's practice this first. So let's convert. I'll give you a few questions here. We have to do this before you're able to compare and order fractions and decimals. So let's do number 1 here. Okay, so convert the following to improper fractions. Convert the following mixed numbers to improper fractions. Okay, so let's say example A, let's give you 4 and 4/11. What would that equal as an improper fraction? I do encourage you to pause the video to figure this out before I go for the answers. And another one is, how about 8 and 7/8? Okay, so again, pause the video, figure this out yourselves. So as a reminder, remember that what you're doing, and maybe I should write the note up here, is when you're converting from a mixed number to an improper fraction, you multiply the numerator, or sorry, not the numerator, the denominator by the whole number. Then add the numerator. And remember, the denominator stays the same in both cases. Denominator stays the same. Okay, so go ahead and figure out 4 and 4/11 and 8 and 7/8. Pause the video right now and go ahead and work that out. I'm going to continue. So again, as stated before, the denominator has to stay the same in both cases. And remember, with an improper fraction, the numerator has to be bigger than the denominator. So I'm going to follow the cycle of steps. Okay, so again, 11 stays as the denominator in both cases. So I'm thinking to myself, what's 11 times 4? Okay, so that's 44. And then you're going to do 44 plus 4 because you're adding the numerator. That becomes 48. So the equivalent improper fraction is 48/11. Okay. For the other example, we have 8 and 7/8. Again, set yourself up. You know that the denominator still has to be 8 because it's equivalent. So again, I follow the cycle. So I'm going to go 8 times 8, which is 64. 64 plus 7 will give me 71/8. Okay. So again, converting mixed numbers to improper fractions most people find it a bit more straightforward. I do myself. We have to go the other way. So going the other way, I'm going to do 3 examples. I'll do one with you. So convert the following improper fractions to mixed numbers. Okay, so let's set ourselves up with this. Let's do the first example together. So let's do with A. sort of something, okay, let's do over 4. Okay, let's do, actually, let's do, 9 over 4. Okay. Now, this involves division. So what you're thinking about is, again, same thing, okay? The denominator has to stay the same in both cases. Now, remember that whatever fraction accompanies this mixed number, it has to be a proper fraction where the numerator is smaller than the denominator. So I think to myself, again, 9 divided by 4, approximately how many times is that, like, or the closest whole number? I know the closest whole number without going over is going to be 2, right? So, because I know that 2 times 4 is 8, and actually that should be, because I know 2 times 4 is 8, so I know 9 divided by 4 approximately is 2, because that's the closest I can get without going over. And I think, okay, so what's the remainder? Well, I know that I'm left with 1/4 because I'm only that much away from 9. So I know that the equivalent mixed number is going to be 2 and 1/4. There is a really good way to check your answer because you actually just follow the step as in the examples in number 1 above. So I'm going to follow my steps. I'm going to check and see if I'm right. So 2 times 4, what is that? That gives you 8. What's 8 plus 1? That gives you 9. So we know that these two are equivalent. So again, what you're doing to repeat the steps is you're dividing the numerator by the denominator. You're getting the closest whole number, and that will become whatever your whole number part is of the mixed number. The remainder is what the fraction or the numerator will be. Okay, so again, I'll jot this down just so you remember. So again, when you're converting improper fractions to mixed numbers, you divide the numerator, I'll abbreviate, by the denominator. The closest whole number, without going over, becomes your whole number in the mixed number. And then the remainder is the numerator in the fraction. Hopefully that makes sense. Okay, so now I'm going to give you 2 more examples to work through on your own before you check the answers. So let's do B. How about try 13 over 7? Again, think about the equivalent mixed number. And then finally, let's do one more. Okay, let's do 22 over 8. Okay, so again, pause the video, follow the same procedure as in example 2a. So divide the numerator by the denominator. That closest whole number becomes the whole number in the mixed number, and then whatever the remainder is the numerator of the fraction. I always encourage you to check your answer too, so check your work by doing the reverse operation, like what we did in example 1. So go ahead and pause the recording to do that. Okay, I'm going to continue. So we've got 13 over 7 and 22 over 8. So again, I'm thinking to myself, how many times approximately is 13 divided by 7 without going over? What's the closest whole number we can get to? The closest whole number is going to be 1 because 1 times 7 is 7. Now, what's the remainder? Well, the remainder is how much more do we have to get to get to 13? So if 1 times 7 is 7, we know the remainder is 6 over 7. Remember that the denominator stays the same in both cases. Check your work. Okay, so what's 1 times 7? It is 7. How do we get from 7 plus 6 gives you 13, so you know you're correct. Let's do 22 over 8 to end. So 22 over 8, again, you think to yourself, 22 divided by 8, approximately how many times? The closest whole number that you can get to 22. It would be 2, because 2 times 8 is 16. Okay. So again, how much more do you need to get to 22 from 16? Well, I know I still need 6, and then the denominator stays the same as 8. How do I check my work? Well, okay, again, same procedure. 2 times 8, which is 16, and then 16 plus 6 should give you 22. I also encourage you, it's always good practice to reduce fractions, because if you look at 2 and 6/8, you can actually still put that in lowest terms. Think to yourself what number, the greatest number that 6 and 8 are divisible by. Or you're basically finding the GCF of 6 and 8. In this case, it would be 2, because you can divide the numerator and denominator by 2, so it does reduce to 2 3/4. Okay, so that's a review of improper fractions to mixed numbers.